Hi everyone. So this is going to be another video of our ongoing Google Prep series. Okay, this what usually happens in our Prep series is we take up problems which were already been asked previously, and what you have to do is you will pause the video when we'll share the problem statement, try on your own, then look at the solution. Okay, it is going to be helpful for you in that way. If you can find other prep series on our official YouTube channel Wise Coder, so please do check it out. Let us jump into the problem. This is one of the problem which was shared to us by one of our student, which was actually asked in recent interviews like 2 weeks ago. So it was like this. What they shared us. So given a pair of connection of people, find the number of people who don't know each other. They don't know each other if they don't have a connection, or A and B are connected if C is connected to both of them. Okay. So there are two parts. We'll cover the second part after we are done with the part one. Question was like people who meet every day instead of connections. Like here, it was a story based problem. Like if people are meeting, you are given details about like N and M, where N is going to be number of people, M is going to be pair of connections, or basically people who meet daily. Okay, it is going to be something like this. I'll explain you what the best problem statement I can build from here. So, what details are given to you is there are N people, okay, and we have details about M pair of people, okay. What is that detail? If it is mentioned 1 comma 2 or 1 2 as one of the pair, if one of the pair is 1 2, it means these two people meet daily. These two people meet daily. Okay, those who meet daily, you can tell they know each other because they are meeting daily. Okay, a third person, suppose there is a person 4, I can say that this person 4 knows one if person 2 is connected to 4. Okay, if something like this is there, although 1 and 4 are not directly connected, I am not using the term connected. Let me, what I can say, take more examples. Suppose we have 2 4, we have 3 2. So here I have something like this: 1 knows 2, 2 know 4, and 2 also know 3. So 4 indirectly knows 1 and 3. Okay, it's like that. The problem statement which I can build from here, it's something like this. What you have to find is you can have something like this: 6 and 7 know each other, 8 and 9 know each other, then 5 and 9 also know each other. So we can have group of like friends, you can assume. 1 2 3 and 4 are first group, 6 and 7 are second group, 5 8 and 9 are third group. So there can be different group of people. How they are forming this group? If they know mutually, also if they know somebody, they are part of same group. Okay, now, what the problem statement here is asking you to do, find number of people who don't know each other. Okay, it's like assume, relate to it to your normal day-to-day life. You have a group of friends. There is some other people who have their group of friends. These group, like people, person 6 don't know person 4 because they are not in the same group. So it is asking you the same question, number of pair of people who don't know each other. Okay, that is the best problem that I can form from the given information. Okay, so there can be 5 1 2 5 9 2 6 2 7 1, something like this. Okay, because these people are not part of same group, so they don't know each other. Or in simple words, they are not friends of each other, so they don't know each other. Okay. So how now you need to understand this is what is given to you. You can treat whatever information is given to you as a graph. Okay. You are given a undirected graph. Okay. What is the format? Even from the input format, you can understand an M. N is number of people, you can say number of nodes. M is pair of people, you can say the connection or the edges. Okay, the pair of nodes between which edges are there. Now, what you have to find number of people who don't know each other. So you need to find number of pairs who are not connected, who are not connected. This you should be able to visualize. Okay, because you are preparing for Google interview, so you should be aware of basic or some thought process should be there. Like you should be able to identify this is a graph problem or something like this. Okay, now coming to this part, you have to find number of pair of nodes who are not connected. Now connected in the sense 1 and 3 are connected because from 1 you can reach to 3 or they all are part of same group. Okay, so that you have to find. There is one very like the same problem is there available on the lead code 2316. You can pause the video here and try to solve this particular problem. Write the code, try to submit it. It is almost the same problem which was asked. Now coming to this, how we can solve this particular problem. Okay, I'll take the same example. Okay, here if there is any way these people are of group 1. These people are of group 2. These people are of group 3. In any way, I can find how many people are there in which group. How many people are there in which group? If I can find that, I can easily find how many pair of people are there who don't know each other. Okay, I'll take the same example. I'll just copy this one a bit downwards. Mm, just a second. Okay, seems fine to me. I'll copy and scroll down, and here we'll see. So I have something like this. Yeah. Can I move it down a bit? Mm, no. Yeah. Now fine. Yeah. Perfect. So these are three groups. So what I want to know is in group 1 I have 4 members. In group 2 I have 2 members. In group 3 I have 3 members. Is there any way to find this? Yes, there is a way. How we are going to do this, or let me tell you the approach, then we'll see how we are going to find this. Now once you have the numbers, obviously all for all these people, all these 4 people, you can form the pairs. Okay, and obviously the problem is not clear, like you'll count 1 5 and 5 1 differently or as single. We'll skip this part. As of now, we are counting like 1 and 5 and 1. We are assuming both pairs are same. Okay, because they are same set of people. So we are assuming like that. Okay. Now coming to this, people in group 1, we have 4 people. For those 4 people, these remaining 5 people are unknown. So, for every person of group 1, there are 5 people. There are 5 people whom they don't know. So, how many pairs they can form? One person can form 5 pair. 4 people are there, so 5 into 4 is 20 pairs. Now, which 20 pairs? Like 1 5, 1 9, 1 8, 1 6, 1 7. 5 option is there for 1. That's how 5 option is going to be for 12. Sorry, 2 also. 5 option is going to be there for 4 also. 5 option is going to be there for 3 also. So 5 into 2, oh, 5 into 4, 20. So 20 pairs you can form. Now you'll go to next. You'll go to next. Now for this particular group 2, you can form, these are the remaining, these are the people of remaining group which are unknown, because this group 1 people you already have formed the pair. Okay, we already have formed the pair with group 1 people. So for this group, how many people are there in this group 2? We have 2 people, and for them now 3 people are unknown now. Okay, we already have counted these 4 people of group 1. Okay, now for them, how many options are there? For one person we have 3 unknowns, so for 2 person it is going to be 2 into 3, which is 6. So total number of pairs till now is 26. Now for when you go to the group 3, you already have formed all the pairs, because for group 3 they have unknowns from group 2 which you already covered, they have unknowns from group 1 which you already have covered. So once I have the count of all group, all different group, how many people are present in all different group, I can find the sum, or total number of people are going to be n. In this case it is 4 3 7 2 9. Okay, I'll basically iterate through them. I am going to maintain an array which is going to store how many people are present in which group. Okay, so this array is going to be like this: 4 2 3. I go to the first element. Now 9 minus 4. I'll do 9 minus 4, which comes out to be 5. It basically means 5 people are unknown for me. How many people I this group have? 4. So 5 into 4 is 20 pairs I can form. When I go to next, now how many people were there unknown? 5. So 2 I have to cover here. So it will be 5 minus 2, which is 3. So for this group, 3 unknown people are remaining, because 4 we already have matched with. So in this case, number of pair is going to be 3 into 2, which is 6, and sum will be 20 plus 6, 26. And we finally go to the last group, and number of people who are remaining is 3, and this group also have 3 people. So for it, no more unknown people are there. As you already know, they already have formed the pairs for group 2 and group 1, so we don't have to count it again. Okay, pause the video at this point and try to understand what I just explained to you. Okay, you might find this a bit tricky, but if you just roll back and see it again and again, you will be able to find. Okay, what I'm saying is very simple, very simple. Just one more time I'll repeat so that it's clear with you also. Okay, it will take a minute or so. Just a second. So what is there? Total number of people, how many are there? 9. You are basically, you have an array which store in which group how many people are there. In group 1 we have 4, group 2 we have 2, group 3 we have 3. So you'll iterate through them. In group 1 I have 4 people. Total peoples are 9. So how many are remaining? Remaining are 9 minus 4, 5. These are the people who are not part of group 1. So you can form the pairs. How many pairs are going to be formed? 20. Next time when you go, you have to update how many people are there. Why you need to update? Because these 4 people you cannot use again. Na? Whatever pairs that were possible for these 4 peoples and all other groups, you already have formed. Okay, you already have formed this 1 6 1 7 group. So there is no point of counting this again for group 2. Even similarly, you have formed the pair between 1 8 1 9 and 1 5. There is no point of counting them again. So these people are gone. You have utilized them. Now remaining people are going to be 5 only. 9 minus 4. These 4 people you lost them. So your count is also going to be updated. Now number of people left is 5. And how many people are there in group 2? We have 2 people. So how many people are not in group 2? That is 3. So with them you can form a pair of people who don't know each other. And how many pairs are going to be formed? 3 into 2, which is 6. Okay. And finally, when you go, so here 3 people were remaining. When you go there, 3 minus 3 comes out to be 0. Because Number of people are three, and all the three people are present in same group, so you cannot form any, or there is no person outside this group. Okay, you cannot form any pair. So 20 plus 6 is the right answer. 26 pairs you can form are the people who don't know each other. Now, coming to how we can find which all people are there in each group, that is very simple. There is like a way. What you can do is you are going to run a loop starting from 1 till n. Okay, and you will check if this node is visited or not. If this node is visited or not, if this is visited, like you need a visited array. Initially, it is going to have length n plus 1. We are assuming all the nodes or people are numbered from 1 to n. Okay. So we created this visited array of size n plus 1, where every index 1 onwards is corresponding to that person. It is 0. Okay. Now here, if I have not visited this person, it means I found a new group of people. Okay. So I'll normally do a DFS. Okay. So once you run the DFS, suppose from node 1, you'll mark it, you'll go to neighboring node, you'll mark it, you'll go to its neighboring node, you'll mark it, you'll mark it. So all these nodes are going to be marked, and you'll also be able to count. So from here you can get the count and which you can store in array. Okay. So using DFS, you'll be able to count how many nodes are there in each of the groups. Okay. We are going to consider or take utilize the input. Whatever input is given to us, we will form the graph from there. I already told you, you have to visualize. This is a graph problem. Okay, we will come to the implementation part of this. I'll implement in front of you only all the things. Okay. Now coming to the part 2. So this problem is solved. I told you how we are going to find the pairs. For this, what is important is we need an array which contains like size of every group. Okay. Once it is done, then it is simple. We just discuss. Now there is the second part of this problem. The second part of this problem is find number of bridges required to connect each other. Now we have three groups. As we discussed, there is one group 5, 9, 8. There is other group 7, 6. There is other group 1, which is connected to 2, which is connected to 4, which is connected to 3, I guess. Wait, what was the other node? Yeah, 2 is connected to 3. Okay, now these are three groups. So what they are asking is, what is the minimum number of bridges or minimum number of connections you need to add so that everybody become friends? Okay, so here in this answer we have three groups, so you require only two connections. You can connect any of the two groups together, any of the two groups together. Oh, sorry. Not any of the two. You need to have like two connections. Okay, between the groups. The three groups are there. So we have, suppose this is group three, this is group two, group one. So we can have one connection between group two and group one. Like suppose one and seven know each other, and one connection can be between any people from group three and any person from group two. Okay, so the point here is it is very simple. The second part is very simple. Like you know how many different groups are there. If number of groups are three, you require only two. Only two connections you need to do. Those connections can be anyone from group 1 and anyone from group 2 and anyone from group 2 and anyone from group 3, or you can have anyone from group 1 and anyone from group 3, anyone from group 2 and anyone from group 3. Okay, so that it can form a list or group of friends, everyone where everyone is part of it. Okay, so that is the answer in this particular case. Okay. Now let us see the implementation part. I'll try to write implementation from scratch here. Okay, I'm going to use C++ for implementing. If you want to implement on your own, you can skip this particular part. So you can stick to it how we can build from scratch. I can zoom it a bit. So what we are going to have is I just included header files. We are going to have a main function. What else? We are going to have how many people are there and how many connections are there. Then we are going to create a graph of n plus 1. Why n plus 1? Because here I want to have every person is um, represented by index from 1 to n. So that's why I need to create an array of size n plus 1. Now we were going to run a loop m times. These are details about the connection. Okay. We will be given details about person 1 and person 2, or in if we are talking about graph, these are the nodes, two nodes u and v. Okay, I'll say for graph u, v is one of the neighboring node. Okay, that's how we take input and create graph. Okay, we are maintaining a adjacency list, like we are maintaining list of neighbors for every node. Okay, once we have this, what is our first goal? First, I want to have a list of how many people are there in each group. Okay, so I am going to have like groups. Okay, then what else we require? We require a visited array of size n plus 1. Initially, it is going to be 0. I'll simply go through them 1 to n plus plus I'll say if I have not visited this person, or if this person is already visited, skip it, move on to next person, check if they are visited or not. If I found a person who is not visited, it means I found a group, and there I will perform DFS to cover all the nodes of that group. Okay, I is going to be the starting node, and graph is required, visited array is required. Okay, now see what this function is going to return me is it is going to return me the size. What is the size of, or how many people are there in this particular group? I'll add this particular value in my groups array. Okay, groups dot pushback. See, now here we have to find how many pairs can be there. So assuming number of nodes can be up to 10 to the power 5. Number of pairs that we'll be able to form might be out of integer limit. So we are taking a long, which will count how many pairs are there. And we will simply go through how many groups we have, details about that, as I told you. So what is going to be there is initially how many total people we have. We have n number of people. Okay, when I'm going to any index of my groups array, so now total number of people are going to decrement by that much. Okay, now what total is storing is, it simply means in this group I have this many number of people, and those many number of people I need to remove from total number of people now to find people who are not in group I. Okay, so in this case, total pairs that is going to be formed is, these are total how many people who are not part of this group and how many people who are part of this group. Okay, that is going to be added. What is this? People who are not part of this group. And what is this? People who are part of this group. Like these are the people, as I mentioned here, these are the people who are not part of your current group. And what is this? These are the people who are part of your current group. Okay. So we need to multiply, like in group one, I have three people. And People who are not part of group 1 is 6. So how many pair I can found? 3 into 6. For every node of this group, I have 6 options. So for 3 nodes, I have 18 options. Okay. Now you need to be careful here a bit because you are dealing with int and long together. So yeah, I just did this typecasting. I converted everything. And here we will print how many pairs we can form. Okay. That is the code for it. Now what we need is we need to create this DFS function. Okay, this code will be shared with you, even the problem word file of this problem statement. So I want to have this DFS function where I have node, I have details about my graph and visited array. Whenever I'm going to any node, first task is to mark it as visited. After that, you are going to go to all the neighbors of this particular node. If the neighbor is already visited, you have to continue, move on to next, else you'll visit that neighbor. Okay, let us have a count which will be how many neighbors are there or how many nodes you can find which are not visited or part of your current group. So because this DFS function is going to return, whenever you are going to make a recursive call, it will find how many uh, people are there in this group. Okay. And what you have to return? You have to return C plus 1. Why C plus 1? Because you have to count this current node also. Now this is also part of same group. Okay. So this is the DFS function which we created for counting which all nodes are there and also marking them at the same time. Okay, so that is the code for it. Let us run it. We need to take the example which we had. The example is how many nodes we had? 9 nodes were there. And let's see how many edges we had. We had 2, 3, 5, 1, 6. So 6 edges were there. So 9 nodes, 6 edges, 1, 2 were connected, 2, 4 were 2, 3 were connected, 2, 4 were connected, then 6, 7 were connected, 5, 8, 5, 9. Okay, so let me count again. 1, 2, 3, 4, 5, 6. Yeah, 9, 6 seems fine. The answer for this we got 26. Let's see if it is correct or we did some mistake. Yeah, so it is giving us 26 as the answer, and I already explained you. And here in this case, how many groups are there that I can also find? How many groups are there? Number of groups is equal to the size of this array, that array we formed. So number of groups is equals to that much. Okay. And what is the minimum number of connections that we need to add extra to make it connected? It is number of groups minus 1. Okay, that many connections we require. So in this case, it should print 2 because 3 groups are there. So 2 connections we require. Okay, yeah, it is working fine. If you have any questions, any queries, you can obviously ask. Okay, that's all. Thank you.